We are all bound by absolute democracy of time. Every single one of us in this room receive exactly 24 hours a day, no more, no less. But on a university campus, time isn't always lost to studying or emailing. It is stolen by systematic invisibility. Imagine you are a student parking at your car at QRU car park or the medicine faculty lot. Class start in minutes. You look down a long empty stretch of airport. There is no bus schedule. There are no updates. You find yourself trapped in the paralyzing calculation. Do I stand here under the scorching sun and wait blindly for a campus shuttle van that might be delayed or whose driver might be absent? Or do I start walking, arriving at my lecturer hall completely exhausted? My name is Ang Mei Chi. As a student, I'm trained to look at system and root out inefficiency. When our team, the Power Rangers, look at this transit loop, we discover a jarring statistic. Our peers were throwing away an average of 100 minutes every single week, simply waiting for a van to arrive. There is over 6,000 minutes an academic year lost to date time. Today, I want to take you through how we designed, tested, and empirically validated a cost-free digital solution to give students their time back. During our empathic and defense stage, we spoke directly with students and lecturers who rely on this transportation daily. What we discovered wasn't just a logistic issue. It was an emotional one. Students are constantly checking their phones repeatedly for updates that didn't exist. They told us phrases that truly stuck with our team. Friends, I have been waiting for 20 minutes already, and the van is always full during peak hours. This lack of service visibility creates an invincible cloud of morning panic, leaving students feeling frustrated, powerless, and anxious before their class even begins. Our quantifiable impact metric proved that this is an epidemic of wasted time. 100 minutes away completely gone. This leads us to our core design challenge. How might we restore a sense of control and certainly to our campus commuters without forcing the university into heavy capital expenditure? To truly understand the human weight of this issue, we didn't just look at the road, we looked at the data. We launched an investigation and collected survey analysis across our campus. Look at this reality: 77.8% of our student community drive to campus, and nearly half of them, 47.1%, are forced to utilize QRU car park A and peripheral medical faculty lots. They are highly dependent on shared transit. Yet, 44.5% of these commuters confess they are never used the caravan service. Why? Because uncertainty breeds avoidance. Our empathy mapping captured deep-seated user pain points. Commuters describe checking their phones repeatedly for updates that never came. There's proof of the morning panic when a van would pull up completely full, leaving them stranded. The root cause was an invincible transportation grid. Our design target became crystal clear. We had to build a real-time van tracking experience inside our existing QRU Connect mobile platform. But we had to do it without increasing operation costs for the university administration. To solve this, our team turned to the strict contradiction metric. We discovered a profound technical contradiction. If we introduce continuous, high-end, real-time GPS tracking hardware and intense cloud network infrastructure to improve transit convenience, then our operating, maintenance, and data costs will skyrocket. How do you build a highly accurate live tracking infrastructure when your budget is exactly $0? If you turn to traditional engineering, you encounter several technical contradictions. Continuous GPS satellite streaming requires expensive hardware beacons and constant cellular data subscription, which break the financial boundary of the university. To break this deadlock, we turn to a strict contradiction metric. We bypass expensive physical hardware by leverage Principle 10, preliminary action, and Principle 23, feedback. Instead of purchasing expensive sensor, why not use preloaded local caching over free campus Wi-Fi? And more importantly, Why not transform our user base into a self-correcting community network? We realized that the students standing at the platform could serve as the ultimate life sensors. Our improving parameter was convenient ease of operation, but our worsening parameter was operational cost. Instead of compromise, choice guided us to work for powerful intensive principles. Principle 10. Freeloading maps and schedule over free campus Wi-Fi while students are still in the classroom. Principle 23, which is feedback that transforming the student communities themselves into a live source sensor loop. Principle 25, self-service bypassing manual admin coordination so students plan autonomously using self-assessed portals and digital station QR codes. By deploying these principles, we realized we could bypass expensive dedicated hardware by using preloaded, intelligent, and crowdsourcing. Now, let's step into what we actually built, simulated, and put into the hands of real users. We created a low fidelity interactive paper prototype mapping out the full user journey within the updated QRU Connect app. This brings us to our core milestone, the prototyping and user testing architecture. We didn't just build a pretty interface, we elevated an end-to-end user loop. We started with low-fidelity paper wireframes, as seen in our Sketch 2, mapping out a simple 8-stage journey from login to road viewing, and finally to a basic review screen. We then upscaled this architecture into functioning high-fidelity digital application. As outlined in our campaign launch poster can service Power Rangers. The updated When Connect function integrates live tracking maps, offline local timetables, and interactive user report screens. We stress tested this prototype using two distinct methodologies: a control 6 participant lab test at LaPlus using a think aloud protocol, followed by a campus-wide testing deployment using our feedback metrics. Let's look directly at the empirical testing result from our user community. Documented in screenshot, when we elevated the primary feature, the real-time digital location map, the feedback was overwhelming positive. 66.7% of users explicitly stated that the live tracking map helped them manage their commute. In terms of clear unity, 44.5% of participants give it flawless 5 out of 5 rating for usefulness, with an additional 22.2% rating it a 4. Commenters note that this feature allowed them to map out their morning timelines and choose whether to walk or wait. The hard data gave us a mixture of celebrating moments and humbling reality checks. For the task 1 login, achieved a 100% success rate in under a minute. For task 2, which is feature exploration, dropped to a 67% success rate. Why? Because behavioral patterns favor unexpected friction. For example, during housing section, our offline map download link through a certain runtime error. Furthermore, she explicitly questioned why an offline map was even necessary if students are used to constant cellular connectivity. 2 out of 6 users labeled the offline map as useless during active testing. For task 3, feedback system interaction dropped down to a 50% rate. While users successfully scanned QR codes, they didn't intuitively understand how their feedback loop updated the back-end server architecture. When we tested our crowdsourced feedback loop, we hit a clear roadblock. We asked our testing group, understand students as feedback system help others waiting for the when. The data split right down the middle. 55.6% say yes, but a significant 44.4% say no. Why this hesitation? Our user experience journeys varied to critical friction points. First, during live simulation, our offline local cache threw an unexpected storage loading error. User openly stated that an offline map feels secondary when cellular networks were active. Second, user highlighted a glaring blind spot. They told us the when is real time, but what if a write at it's completely overcrowded? Look at the raw response from our database. Students explicitly demand higher frequency, greater reliability, and an immediate way to real WAN volumes. We didn't scrap the feature, we adapt them in real time. We integrate an automated when capacity progress bar directly into map screen, as seen in our high fidelity layout prototype final stage. The picture above, which dynamically calculates life density, displaying markers like 60% full. We iterated the user timeline in prototype final stage 2, adding a community feed where active passenger alerts like crowded or seat free auto-populate, ensuring no student waits for a bus they cannot board. This evolution solidified our final integrated innovation and enhanced crowdsourced van service feature built right into existing QRU Connect mobile platform. Our architecture elegantly balanced technology and community collaboration to stay cost-free. The passive track low-cost digital beacons attached to a campus van that interface directly with the app, eliminating heavy central server costs. Next, the active track student as a sensor, which is simple, gamified interactive buttons like when seen at stop and I'm in the van. If a van misses its schedule by 10 minutes and student click no to arrival, the system automatically infers driver absent and send a push notification. This hybrid approach maximizes efficiency and convenience while protecting the university's financial and system maintenance boundaries. Why does this matter right now? This solution directly supports real-world campus sustainability and ESG principles by optimizing resource utilization and campus health. By utilizing existing smartphone, campus Wi-Fi, and a lightweight crowdsourced reporting framework, we eradicated the average 100 minutes of wasted waiting time per student per week. It changed the emotional baseline of our university. Instead of commuter uncertainty, anxiety, and morning panic, we hand students data transparency and absolute control over their schedule. If a student sees the van is full or delayed, they instantly choose to proceed on foot, increasing daily physical activity and completely eliminating wasted transit time. This innovation maps beautifully onto modern ESG guidelines by transforming crowd behavior into a utility asset, with eliminating an average of 100 minutes of wasted time per student every week. We replace anxiety, frustration, and helplessness with flexibility, individual control, and predictability. It gives students the freedom to choose whether to wake productively or walk healthy to class. Our journey as the Power Rangers team proved a vital engineering lesson. Resolving systematic urban and campus problems doesn't require deep financial capital. It requires a dedication to user empathy, structural ideation, and rapid data-driven iteration. Our stakeholders have confirmed a clear problem solution fit, and our next milestone is to for concrete deployment path alongside to the university logistics department and our main drivers. We have built a framework that turns a daily campus fluctuation into an integrated system of community intelligence. The QR code on this screen represents more than just an app feature. It represents our commitment to preserving our community's most valuable asset, their time. Let's emulate transit uncertainty and move together into a smarter, more efficient campus future. Thank you very much.